Hello, in this video tutorial we will be learning about a new chapter that is chemical bonding. Bonding. What does bonding mean? Bonds mean to form a relation, that is, in chemistry it means how two different atoms meet to meet a molecule to form a molecule. So basically we'll be studying three different types of chemical bonding. They are: one, ionic bonding; two, covalent bonding; and three, dative covalent bonding. So let's start with ionic bonding. As the name suggests, ionic bonding has something to do with ions. That is, ionic bonding is formed when ions are formed. That is, when ions are formed. To form ions, the atoms must either gain electron or lose electron. So we know that opposite attracts. Hence, to form ionic bonding, a positive ion and a negative ion should be present in molecule. So ionic bonding is formed between a positive ion and negative ion. Now, how are these positive ions and negative ions formed? It is formed by losing electron, and it is formed by gaining electron. So let's directly jump into the examples. The most simple and most common ionic compound is NaCl, that is sodium chloride or common salt. Now, how is this sodium chloride formed? Sodium chloride is formed from sodium metal and chlorine non-metal. So before its formation, the sodium atom loses an electron and forms a Na plus ion, and the electron which is lost by Na plus is gained by the chlorine atom to form a Cl minus ion. Now there is a very strong force of attraction between the plus charge and the minus charge, and that force of attraction is called electrostatic force of attraction. Electrostatic. Why is it called electrostatic force of attraction? Because due to the presence of charge, that is electrostatic. The electrostatic is caused due to the charges, the positive and negative charges, the opposite charges. So as you know, opposite attracts. So the plus ion and the minus ion are attracted due to electrostatic force of attraction, and we are required to show the electrostatic force of attraction in this way: the dotted lines from the positive to negative. So this is the electrostatic force of attraction. Now the positive ions and the negative ion are attracted and they form NaCl molecule. Now the major thing we need to know here is that ionic bond is very strong. Ionic bond is very strong because the electrostatic force of attraction between the positive ion and the negative ion is very strong, and hence the ionic compound is very strong. Now later we'll learn to compare between the similar ionic compounds and see their strength. We also need to learn how to make the dot and cross diagram. So let's try to make the dot and cross diagram of NaCl. Dot and cross. So dot and cross, as the name suggests, it is dot and cross. We'll label the electrons using dot and cross and show how the bond is formed between Na plus and Cl minus. So in case of ionic compounds, dot and cross diagram is made in this way for NaCl. We know that for the formation of NaCl, Na plus ion must be made. So this is the nucleus of Na plus ion, and we are required to make just the outermost orbit. So in case of sodium, the electron configuration is 281, and since it loses one electron to form ion, the outermost orbit has no electron, so the outer orbit is empty, and hence our Na plus ion is this. And in case of chlorine, the electron configuration of chlorine is 287, and since it gains one electron from sodium, so it changes to 288. It changes to 280. So the outermost orbit of chlorine has 8 electrons, so we are just required to make the outermost electron. And since chlorine has 7 of its original electron, we will label 7 electron using cross. 1, 2, 3, 4, 5, 6, 7, and the chlorine has gained 1 electron from sodium, so the 8th electron will be a yellow electron from sodium, and its charge is -1. So the 8th yellow dot shows the 8th electron that is transferred from sodium to chlorine. Hence the dot and cross diagram of sodium chloride is this. Without this arrow is this. The dot and cross diagram of sodium chloride is this. You need to clearly show the charges plus and minus. Now, what about when an atom gains or loses 2 electrons? So for that, let us consider magnesium chloride. Magnesium chloride, MgCl2. Since magnesium is a group 2 element, it forms Mg2 plus ion, and chlorine forms Cl minus ion. And due to the presence of two Cl minus ions are formed. So what about the dot and cross diagram of magnesium chloride? Magnesium has different configuration of 282, and since it forms plus 2 electron, it loses the outermost 2 electron, and its outermost orbit also has no electron. It is empty. So the dot and cross diagram of magnesium will be this, with 2 plus charge because it has lost 2 electrons. Now what about chlorine? In this case too, chlorine has 287 electron configuration, and it needs 1 electron to complete its octet state. So it changes to 288. But magnesium has lost 2 electrons, so where does the next electron go? The next electron is just here, because we have just seen here that 2 Cl minus ions are formed. So the dot and cross diagram of chlorine in this case is this: Cl and 7 of its original electrons. 1, 2, 3, 4, 5, 6, 7, and the final 8th electron from magnesium. Dot and cross diagram, and it has charge -1, so we'll just write minus. And since 2 chlorine are formed, so we'll write 2 outside of chlorine. And I hope you are confused here due to the yellow brackets. Do not get confused. I'm just trying to show the difference between the electrons. But while you write in your paper, you don't need to change your inks. I'm just trying to make it clear. You just need to write dot and cross, and using dot and cross, you can differentiate between the electron types. Now, this is the simple electron configuration of magnesium chloride. Now, how about magnesium oxide. Magnesium oxide is in the form MgO. So magnesium loses 2 electrons, oxygen gains 2 electrons. Oxygen and electron configuration of 2, 6, and since it gains 2 electrons for magnesium, it changes to 2, 8 for oxygen, and for magnesium it changes from 2822 to 280. So the electron configuration of magnesium will be same in this case too. That is magnesium, and the outermost orbit is empty with 2 plus charge, and for oxygen it's nucleus in the center. The inner O represents the symbol of oxygen, and the outermost orbit has 6 electrons, 6 of its original electrons, 6 electrons. 1, 2, 3, 4, 5, 6. And since it has gained 2 electrons from magnesium, so we'll have 2 dots. This is why it is given name dot and cross diagram. And since it has gained 2 electrons, it has charge 2 minus. So these are the basic dot and cross diagrams of ionic compounds. Why don't you try it alone when trying to make the electron configuration of Al2O3, the dot and cross diagram of Al2O3. Next up, we will be learning about the next type of chemical bonding, that is covalent bonding. Covalent bonding. Oh, I forgot to mention a thing. For ionic bonding to occur, you must at least have a metal and non-metal. Ionic compound is only formed between metal and non-metal atoms, ions basically. And now let's read about covalent bonding. What is covalent bonding? We know that ionic bonding is formed due to the transfer of electron, that is, one ion loses electron and the next gains the same electron, forming ionic bonding. Now what about covalent bonding? Covalent bonding is formed due to the sharing of electron. Sharing. Now what type of sharing? It is mutual sharing. Now let me write the definition. Mutual sharing. What does mutual sharing mean? Mutual sharing in this case means that the shared pair of electron comes from both atoms. That is, both atoms contribute to the shared pair of electrons. Hence, mutual sharing term is used over there. Now, let's not waste our time and directly jump into the dot and cross diagram and example of covalent bonding. Before that, we need to know that for covalent bond to occur, we need to have at least one non-metal ion atom. It's just not at least it is basically between non-metal and non-metal ions. Atom, sorry. Why am I always using atoms? So non-metal atom. It is mostly between non-metal atoms, but we'll learn that in some cases covalent bond occur between a metal and a non-metal too. So let's read about their dot and cross diagram and examples. The very basic covalent compounds that we know are hydrogen, oxygen, fluorine, HCl, that is hydrogen chloride, methane, ethane, etc. So let's read about the dot and cross diagram of hydrogen. H2. Hydrogen is a diatomic molecule. Hydrogen, oxygen, fluorine, all are diatomic molecules. That is, they exist in the distate in the natural state. So H2, it is basically this bond. A hydrogen atom and a hydrogen atom share a pair of electrons to form H2 molecule. So this is the rough dot and cross diagram of H2. Now let us read in detail about the dot and cross diagram of hydrogen. This is the first hydrogen and it has one electron, just one electron. And for the next hydrogen, I'll be using a different color so that you'll be clear. And this is the next hydrogen with its next electron. So I am labeling one electron with a dot and the other with a cross. So they will form bond in this way. The hydrogen, oh sorry, I'll change the color. They will form bond in this way. This hydrogen and this hydrogen share one pair of electron and form bond. And to make the atom, this hydrogen has both the electrons. So this hydrogen atom has this structure and this hydrogen has this atom. I was supposed to make a round circle, but you understand it is a round circle. So if you consider this hydrogen, then if you look closely, then this hydrogen has both the electrons 1, 2, and if you look at this hydrogen, then it has both the electrons 1, 2, because its atom has both the electrons. So in this way, dot and cross diagram of covalent compound is made. You are not necessarily supposed to make the electrons in the orbits. Here you can make it in between. So what about the dot and cross diagram of oxygen? Oxygen, O2. It has also the similar case as hydrogen. O2 is formed between the two oxygen molecules, covalent bonding, due to the covalent bonding between two oxygen atoms. So for the dot and cross diagram, I'll write oxygen O, and we know that oxygen has a double covalent bonding because the electron configuration of oxygen is 2, 6, and it requires 2 electrons to change to octet state, that is to change to 2, 8. So since it requires 2 electrons, oxygen forms a double covalent bond, that is sharing of 2 electrons. 1, 2, since it has 6 outermost electrons, 6, and same is the case for the next oxygen atom. O, 1, 2, 3, 4, 5, 6. Now when the sharing occurs, bond is formed between these two electrons. So now the atom of this oxygen is in this form. Now if you count closely, then this oxygen has 8 electrons, and the atom of the left oxygen is this. So both the oxygen atom has 8 electrons and they have gained the octet state. In this way, the covalent bond is formed between oxygen atom and they have each 2 pair of lone electrons, which are not involved in the sharing because oxygen only forms double covalent bonding. Now, what if there is triple covalent bonding in a molecule? Triple covalent bonding, triple sharing occurs in nitrogen molecule N2, because we know the electron configuration of nitrogen is 2, 5, and it needs 3 electrons to change to octet state, that is to change to 2, 8. It needs 3 electrons. So the covalent bonding in nitrogen is in this form. And since we are just denoting the outermost electron in each case, you must remember that. So Nitrogen has 5 electrons in its outer orbital, and since 3 are involved in bonding, I will make 3 electrons at this side and 2 lone pair, that is the pair that is not involved in bonding. And for the next nitrogen atom, 3 electrons are in this side and 2 in this side. Now sharing in the bonding occurs between these 3 electrons, and for this nitrogen the atom is this, and for this nitrogen the atom is this. Hence the bonding between nitrogen atom molecule is this. Now what about hydrogen chloride, HCl? In HCl, covalent bonding occurs between a hydrogen atom and a chlorine atom. We know that hydrogen has 1 electron in its outermost orbit, and it needs just 1 electron to complete the octet state. So the sharing just occurs between 1 pair of electrons. And for chlorine, it has 7 electrons in its outermost orbit, but just 1 electron take part in bonding, and the other 6 are just 3 lone pair, stay 3 lone pair, and the sharing occurs, and the atom of hydrogen will be this, and the atom of chlorine is this. So in this way covalent bonding occurs. Now in each of our examples we are just studying when 2 atoms are present. Now what about when more than 2 atoms are present in the formation of molecules? That is, the basic compound that we know in that form is carbon dioxide. So let's study the dot and cross diagram of carbon dioxide molecule. CO2. In this case, the central carbon forms bond with oxygen, 2 oxygen atoms. We know that the electron configuration of carbon is 2, 4, and the electron configuration of oxygen is 2, 6. Carbon requires 4 more electrons to complete the octet state, and oxygen requires 2 more electrons. So in this case, since there are 2 oxygen present, each oxygen forms a double bonding with the carbon, and double bonding from this and double bonding from this combines to give 4 bonds, which completes the octet state for carbon. So now let's study the dot and cross diagram in carbon dioxide. The central carbon has 4 electrons in its outermost orbit, and since all of them are involved in the formation of bond, so 2 in this side and 2 in this side. Now the 2 oxygen atoms are in the either side of carbon, and the oxygen has 2 bonding electron, and the rest remaining 4 act as bond lone pair. Same is the case in this oxygen too. Now the sharing occurs between these 2 electrons and these 2 electrons, and the central carbon will have this structure, and the 2 oxygen will have this structure. Now if you count the number of electrons in this carbon, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. It has completed its octet state, and this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. It has completed its octet state, and this oxygen has 2, 3, 4, 5, 6, 7, 8. It has 2 completed its octet state. So the dot and cross diagram of covalent compound is also very simple. Now till now we have studied what is ionic compound, what are ionic compounds, what is ionic bonding, and the dot and cross diagram of ionic compounds, and what is covalent bonding and the dot and cross diagram of covalent compounds. Now let's jump into the third type of bonding, that is dative covalent bonding. Oh, sorry. Ionic bonding is also called electrovalent bonding. So they are basically the same, ionic bonding and electrovalent bonding. Now let's jump into the third type of bonding, that is dative covalent bonding. Dative covalent bonding. So bonding has covalent in its name, so it has also something to do with sharing of electrons. But in this case, the shared pair of electron comes from only one atom, that is both do not contribute, that is it is not mutual sharing. So let me write the definition. So dative covalent is also similar to covalent bonding, that is it is also the sharing of electron, but it is not the mutual sharing. Now let's look into the dot and cross diagram of dative covalent compounds, that is NH4 plus and Al2Cl6. NH4 plus. We must know that NH4 plus is formed in this way. Ammonia combines with the proton to form NH4 plus. So before learning the dot and cross diagram of NH4 plus, we will need to first learn the dot and cross diagram of ammonia. So we know that in ammonia, 3 hydrogen atoms are present, and we also know that hydrogen has just one electron in its outermost orbit, so it can form a single bond only. So the nitrogen atom, central nitrogen atom, forms 3 single covalent bonding with 3 hydrogen atoms. So among the 5 electrons, 2 act as lone pair and 3 act as bond pair. And now hydrogen has 1 electron. Each hydrogen has 1 electron. So the atom for this hydrogen will be this. The atom for this hydrogen will be this. And the atom for this hydrogen is this. And now since ammonia had shared all of the electrons with hydrogen, so the atom for nitrogen will be this. And nitrogen has gained octet state because it has now 8 electrons. Now this is the dot and cross diagram of NH3. Now during the formation of NH4 plus, this ammonia combines with H plus. Now what does H plus mean? Hydrogen has just 1 electron. Now H plus means this electron is also lost by the hydrogen and it has no electron. So H plus basically means just a nucleus with 1 proton. That is, H plus means just proton. So now this H plus comes over, and since the hydrogen requires 2 electron to complete its octet state, and this nitrogen has 1 lone pair, that is 2 lone electrons, so it contributes, that is it donates its electron to hydrogen, and this hydrogen forms a dative bonding with nitrogen atom because it has formed a bonding in which the sharing of electron just occurs between nitrogen and hydrogen, in which both of the electrons are contributed by nitrogen. So this is not mutual sharing. And now NH4 plus is denoted in this form with the plus charge from a removed and written at the outside. So this is the dot and cross diagram of NH4 plus. So again, both of the electron for this hydrogen is donated by the nitrogen because the hydrogen has no electrons. So this is although it is the sharing of electron, because nitrogen has given its electron, it is not mutual sharing. Now let's look at the next example of dative covalent bonding, that is in the compound Al2Cl6. Al2Cl6. Al to Cl6 means just two molecules of AlCl3. So this Al2Cl6 is called dimer because there are two molecules of the same molecule. Now before learning the dot and cross diagram of Al2Cl6, let's learn the dot and cross diagram of AlCl3. AlCl3, since the bond is between aluminum and 3-chlorine, so all of the outermost electron of aluminum is used in the formation of bond. That is, all of them act as bond pair. So one electron in this side, one electron in this side, and one electron in this side. And now for chlorine, one electron is used in formation of bonding, one is used in the formation of bonding, and one is used in the formation of bonding here, and other act is lone pair. So the atom for this chlorine will be this, the atom for this chlorine will be this, and the atom for this chlorine will be this, and the atom for the aluminum will be this. So in this way, covalent bond is formed between AlCl3. AlCl3 has covalent bond, but if we pay a close attention, then the aluminum hasn't gained the octet state. That is, it has just 6 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6. Just 6. So, to gain the octet state, this AlCl3 molecule forms dative bonding with the next AlCl3 molecule. So, let me make a dot and cross diagram of next AlCl3 molecule over there. One electron on this side, one on this side, one on this side, and for chlorine, one involved in bonding, one involved in bonding, one involved in bonding, and the rest three act as lone pairs. So the atom for this chlorine would be this, the atom for this chlorine is this, and the atom for this chlorine is this, whereas the atom for the aluminum is this. Now since both of the aluminum atom hasn't gained octet state, so dative covalent bonding occurs between both of them. In each case, this aluminum requires 2 electrons and this aluminum requires 2 electrons. So the chlorine from this AlCl3 donates its electron to this aluminum. Look at the arrow where I am pointing it. The arrow shows which atom is donating its electron. So the arrow from chlorine to aluminum shows that chlorine is donating its electron to aluminum, whereas this chlorine donates its electron to this aluminum. So this shares its electron with this chlorine shares its electron with the aluminum over here, and vice versa. So the rough diagram for AlCl3 is this: AlCl, and it forms dative bonding with this chlorine. So the arrow over here, AlCl, and this gives its electron to this. So this shows the diagram, that is dot and cross diagram of Al2Cl6. Now, one last thing you need to know here is that after the formation of dative covalent bonding. This bond also acts as a covalent bond. So after its formation, dative covalent bonding and covalent bonding are just same, and covalent bond is also very strong. Covalent bond is also very strong, but the strength varies. Although in some cases it is very strong, in some cases it is very weak. So we'll learn about the strength of covalent bonding in the following lectures, in the following video. So this is all we need to learn in this tutorial.